Hey guys, welcome back to my YouTube channel. Today I'm doing a simple question that's called valid anagram. Given two strings S and T, return true if both are valid anagrams or not. So anagrams is a simple term, and that is like uh, given two strings S and T, whether they have same amount of characters with same amount of frequency or not. That's about it. So for example, CARR is also equal to RRAC. This is just reverse, but A can be anywhere, like RARC somewhere like this. And we see that there are two R's, one A, one C, all of that. And this is as simple as it gets. So we need to maintain two either hash maps or char maps. Char maps is a much more efficient version because we do not get the overhead of hash map as an object. And also we can do it using two hash maps and char maps, and we can do it using one char map, which is a much faster version. I'll show all the approaches. Let's start with the hash map one. Hash map character comma integer s map equal to new hash map character comma integer t map equal to new hash map. Now one thing to think about: for a valid anagram, they both have to be of same length, correct? Because if they are not of same length, it obviously does not have same characters with same frequency, correct? So I'll just put an if condition. If like s dot length not equal to t dot length, then return false. Simple. By doing this, we prevent like two for loops, uses of two for loops like s map and t map, creation of s map and t map separately. And as well as another thing that we do is prune when length of both are not the same. So if both of the strings length are not same, we just directly return false and do not even enter the for loop, so it becomes much faster. Yeah. So for int I equal to 0, I less than s dot length, and I plus plus, I'll just do like this: s map dot put s map dot put s dot char at I, s map dot get or default s dot char at I, comma 0, comma plus, not comma, my bad, plus 1. And similarly we do the same thing for t map, like this. So t map, put t dot char at I in t map dot get or default t dot char at I. That's about it. And just see whether both the hash maps are same or not. S map dot equals t map. That's about it. And we need to return it, obviously. This should be pretty simple. Yeah. And I'll show you the char map version as well, which is also like quite same. So just instead of this, what I'll do is int t map equal to new int of 26, and similarly int s map equal to new int of 26. Alright, now we have this and this. What we need to do is s map of s dot char at I minus a plus plus, and similarly what we'll do for tmap is tmap dot char at I plus plus, and what I will do is not this. So for I'll create another function, public boolean to map same, where I will put two integer maps, smap comma int tmap. These are integer arrays. This is pretty simple now from this point onwards. So for int I equal to 0, I less than 26, I plus plus, we just need to see whether s map of I equal to t map of I. Actually, we need to check this continuously. So if this is not true, if s map of I not equal to t map of I, we just return false, and otherwise we return true. That's about it. This is the same as like this, and finally we return here to map same of s map comma t map. That's about it. Yeah, s map dot t map. Oh, my bad. Sometimes I get frustrated when I forget this kind of stuff. This is same as the previous one, but it is much faster because like we are reducing the overhead of hash maps. Char maps are just integer arrays. When we know like stuff is bounded within characters, it's much simpler. So yeah, like this kind of maps are better for these cases. And one another optimization that we can do is that we can optimize via space, so we can use only one map. We can keep a common map and check whether all the elements inside that map are 0 or not. Yeah, that's about it. This is like okay, I'll just keep char map equal to new and 26, and char map, and what I'll do is I'll add the elements of s dot char at I, but I'll reduce when I find the same element at t, reduce the frequency of it, and if everything is 0 at the end, then we return true. That's about it. It is a is map 0, and in that we just put char map, and similarly I'll change this function is map 0, and char map and char map of y not equal to 0, return false. This would be about it. This is a space optimization, making this code much faster. Yeah. So I showed you all the three optimization. For the first case, we have O of 2n, like not 2n, O of n itself, but like we need 2 iterations, right? One through, but it's still O of 26n. Both, all the cases are in worst case scenario O of 26n. And about this, this is O of n itself, and at the end, like we are just checking at constant time everything. I think no, sorry. The first approach was also O of n. This approach is also O of n. Every approach is O of n, but yeah. Only thing is that in this we use only one map. For first and second approach we used 2 maps, but the first one was slower because of HashMap overhead of Java. That's about it. Everything is O of n, O of 26, O of n, O of 26, O of n time, O of 26 space, O of n time, O of 26 space. Yeah, that's about it.